Let's continue our discussion on solving systems of linear equations by looking at this system here. 3x plus y equals 10 and 9x plus 3y equal 13. Now, you can do this by either solving by substitution or solving by elimination. I'm going to solve this using the elimination method. Now, the way this is right now, we cannot add those equations together and eliminate a variable. So I'm going to take the top equation and multiply it by -3. Now you'll see when I do that I get -9x minus 3y equals -30. Then I'm going to take my second equation that I haven't done anything with and write it below. Now you're probably wondering why I chose -3. The reason I chose -3 is because we want either the x terms or the y terms to add out. If I choose a -3, -3 times 3 is -9, which added to 9 gives me 0. Now, if I add those together, what happens to the x's? They go to 0. What happens to the y's? They go to 0. So I have 0 equals -17. Well, we all know that that is a false statement. That means that these lines are parallel and there is no solution. And remember, if we have no solution, we have an inconsistent system. Now, let's take a look at this other example. X plus 2y equals 4 and 7x plus 14y equals 28. And again, we'll solve this system of equations by using the elimination method. So I'm going to multiply the top equation by a number that will make this 7 go away, and that would be a -7. So multiplying each of these through by a -7, I get -7x minus 14y equals -28. Now I'm going to write down the second equation, which I haven't done anything with yet. And you can see on this one that the 7's, the 14's, and the 28's all add to 0. So we get 0 equals 0. Well, the variables were eliminated, but we get a true statement this time, which tells me that we have infinite solutions. This is just two equations that ended up being the same line. Now, when we have infinite solutions and we have two variables, this is the way that we're going to write our solution. We're going to let y equal any real number. Now, it doesn't really matter if you let y equal any real number or x equal any real number. But for our uses, and so everybody will be consistent, we're going to let y equal any real number. And then what we have to do is take one of our two equations, and it doesn't matter which one since they are both the same, and I'm going to write it down and solve for x in terms of y. So I need to get the x by itself, which means I will subtract 2y from both sides, and x will equal 4 minus 2y. So our solution when we have infinite answers is x equal 4 minus 2y, and y would be any real number.